Hi folks, and welcome back to Physics with Captain Rod. I'm making this video here to help you out with number 11 here in your Unit 4 homework. So what we're looking at, we have this system here. This is the 70 kilogram beam right here. That's this right here. And that's really what this problem is all about. You're going to want to start with a free body of that beam. Now, I probably would just define our system like this and just include Timmy. And I'm going to leave that up there for this discussion. Defining our system like this, right, we're going to have a weight vector for Timmy and label it accordingly. So this cable crosses our system here. That's going to apply or create some sort of tension in this direction. You've got a gravitational force for the beam. That beam weighs a little less than 700 newtons. And then you have to say to yourself, what's happening at the pin? There's a contact point. Those are the types of forces we generally put in component form. So start with a good free body of that beam. Right? I've got just a partial free body. You should have a complete free body, all forces labeled. The next thing to do, right, is write a torque equation about this point right here at the pin. And the reason is because any forces occurring at the pin will not show up in that equation. And then you've got a gravitational force vector acting at the center for the beam times this distance, because remember that force acts all along this line. And that should be not too big a deal to handle. All right, here's an angle you should be able to get from the geometry pretty well. The hypotenuse of this triangle should be no problem, I think. It's a 5-meter beam. Okay. Now, here's an angle which you should be able to figure out reasonably well. And I will tell you right now, the torque term will have a t sine theta times the appropriate distance, and that's your theta right there. And that torque is clockwise. And then Timmy's weight, right? If we think about this in component form, here's a different theta. I'll call it alpha, I guess. But that weight vector times the sine of that angle times this distance right here will get you that torque term. Or, this force acts all along this line. You can take Timmy's weight times this distance. Also will correctly tell you, or be correct for the torque term. So get the free body done, write that torque equation, and the only unknown, if you sum torques about this point, will be that tension right there. So hopefully that'll get you through that problem. Have a great day.